So this is my part 3 assignment for Eapd. I'm going to walk you through my Visual Studio, my automated testing and folder structure and things like that. This is the part 3 demonstration for the GLMS website. So in part 2, it was a monolithic MVC application with the front end, business logic, and data access were all inside one project. And in part 3, I've updated it to be separate into 4 different projects containing the GLMS API, shared, and tests, and web. So firstly, we're going to explain what the shade does. So the shade one is a shade library that contains all common entity modules like client. Let me open it so you can see the models: client, contract status, service inquiry, service request, and service request status. And the enums, both the API and web project references, so that there is a single source of data models. So you can see that it's just the way we can connect with the database by declaring the tables and the table headers and such. So then we have the API, which is this over here. So we have the program CS. But before I get into that, let's just explain what the API does. So this is a new ASP.NET Core Web API. It is the only project that talks to the SQL Server, that handles all the business logic, JWT authentication, file uploads, and currency conversion. It exposes various endpoints that the front end consumes. So we have all of our controllers in here. So what the controllers does is it communicates with the database and with the services that is on the system. And it also connects to the modules in the shared folder. So the program.cs of the API lets you register with the entity framework DB context of the SQL Server connection string, and it configures the JWT barrier authentication using a secret key issuer and an audience from the application settings. So application app settings.json has the connection to the secrets and to the what is this called now again? The connection string for the database. So that helps the controllers and services connect to the database and communicate with it. So an example of how that connects is the auth controller here, which is the auth controller. It handles the login when the front end sends a post request with the username and password. The API validates the credentials. If they are correct, it generates a JWT token and returns it in the response. If they are wrong, it returns a 4.1 authentication status, unauthorized status. Right, then we have our web. So our web, let me just close this and open our web. So our web is the front end, and it got completely refactored. It no longer has any direct connection to the database. Every controller uses HTTP client to call the web API and passes the JWT token for authentication. So this still has all of our controllers, etc. But the code has been updated to use HTTP client to communicate with the API. And then same goes for the data and things like that. So yeah. Let's just see. And then we have our views, which obviously is the main focus of the front end, which controls how the website looks on the front end side or user side. So now we can go on to the deployment. So the system has made a new starter project. So when this new profile is actually the API and web, so those are the only two that needs to be run right now. So I'm just going to let those two run. So you can see it started the API and the web. They both need to be running for the system to basically work. So just gonna give that a second to run. As you can see, it's downloading the system so that it can run. Okay, debugging is finished and it should open. This is the back end and this is the front end. The Swagger UI controls all of the API requests. So for now, I'm gonna do the full one error. So if I go to contracts and I put in try out, if I put in a start date, and then I put in a status and I check execute, you can see that this is an unauthorized error. And then if I do the admin login, I just need to update this. Then I can say execute, and then I should get my token, and you can see it's successful. So I'm just going to copy the token so that I can do the authorize here. And yeah. So now that we have done the Swagger side, I'm going to go to the front end. So this is our front end website. Not much has changed of functionality, since not really much code base has to be updated. It's just like the response of it on how it works that has to be updated, not any actual functionality. But this is the homepage. This is the about us page, just explaining what the business is and giving customers a bit of background. Then we have our services, and if customers are interested in the services, they can contact us and they can make a service inquiry. So I'm just going to do one for the sake of it. So here you can see here's the database. So the service inquiry table would be this one over here. So here you can see that there's only two inputs in here. So I'm gonna put an updated one. I'll use this one. And then I'll say that, and then say hello. And then I will say submit query. And then if I go to my database and I select all of those, select all, and execute, you'll see that the query got updated. And then let me just close this side and oh, I accidentally closed it. Okay, so back to it. Contact as you saw, then we have admin login. So admins share they log in. Save for now. And I see I'm still having the same issue I had last time with the admin dashboard image. That I think I can fix in like, no, it wasn't. I didn't name the web pic or something. So I just updated it to a JPEG, so it should be correct now. So okay, there we go. I keep naming the image wrong. Anyways, so yeah, you can see we have 7 clients, 6 contracts, 5 active contracts, and 3 service requests. So let's just go through it one by one. So you can see we have multiple tests. If you go here, you can see the clients. I think for the sake of this, I'm going to delete some of them just so that we can see the clients delete works. So you can see it worked. Then we're going to add one just for the sake of it. Um, and then we're going to save it, and then we're going to go back to the database, run it again, and then you can see we added another client. Then we can see the details of the client, so we can see if they have contracts or not. Obviously, this one won't have any contracts, this one will have a contract, and so on and so forth. Then we can edit them. So let's say they're not in Johannesburg, they can Cape Town. We can update that, it will update there, and then we can go here and we can check that it updated. Great. Now that we're the clients, we can move on to contracts. So you can see there's a download file and it doesn't work, so that needs to be updated. Or the file just doesn't exist, to be honest. Could be that. So yeah, you can see these are active. We can search for clients over here. You can see which ones are expired. You can see which ones are dropped. So this one's a draft. So we can edit this one. We can say that. Okay, now let's leave it as a draft. Then we can just add a contract just for now. We can put it under Aisha. We can say from today until August. We can say active. We can say service level. We can choose a file. Okay, we'll just use anyone at this point. Um, there we go. We'll say save, and then we will go to service report request. So you can see these are all active requests. I don't think we can make one that is temporary, or saved as a draft. So you can see that it's pending. Then you can add a service request, and we can say this one. And there we go. And then here you can see put that, yada yada yada, and then we can log out. Okay, so that was the website. Now we're gonna move on to testing. So just give me. Okay, so now we can move on to automated testing. So I'm gonna be moving on to the automated testing feature. So first I need to get to file path. So once I'm in the file path, I just run a simple.NET test and it should show all the tests. So I'm now running the automated test suite using .NET Test. The test project contains 16 test unit tests that verify the business logic like contract workflow validation, currency conversion, and file validation, and integration tests that boot up the entire web API in memory using Web Application Factory and make real HTTP request against the endpoints. The integration tests verify JWT security by confirming unauthorized requests are blocked, and they perform a full create, then read data integrity test by creating a client, creating a contract, patching the status, and reading it back to confirm it was saved correctly. All 16 pass. All 16 tests have clearly passed with no failures. So here you can see it is each individual uh, system. So just to show you how it looks on the side of things, let's just close that. we're gonna go to test, run tests. I mean, it should open on the side. So yeah, you can see that they all passed with a green dot next to them, which means that the tests have passed. So it's just gonna run again because I said run test. So here you can see all the tests have passed. So finally, after doing the tests, we can move on to, okay, so there is one I want to show you, which is integration tests. So this is the integration test code. So what it does is it first tests a login request with invalid credentials and asserts that the API returns 401 authorization error. And then the second test tries to access contracts with other token and confirms it is blocked. The third test logs in, gets a token and verifies that get API contracts returns 200. Okay, with seed data, which we saw when we did the API test. So you can see the different tests and they all pass because that's why there is a little thingy on the side. And then here you can see it also all passed here on the side. And then you can see all of them. Yeah, all of the test scores. Okay, now I'm gonna move on to Docker. So we're gonna first be here in Visual Studio, and then we're gonna move on to Docker desktop. So let me just close all of those things, close that. We're gonna go to the first can explain. So there is a Docker file in here, which is this right here. So for containerization, I created a multi-stage Docker files for both the API and the web project. The first stage was uses full .NET SDK image to compile and publish the application. The second stage uses the lightweight ASP.NET runtime image, which only contains the published output. And this multi-stage approach makes the final container image full, much smaller and more secure. So this is the Docker file for the um, API. So all I explained now is all in here. Then we have one for the web. So let me just go there. So you can see it's very similar. So the web project has the same multi-stage structure. Then we have a Docker Compose YAML. Let me just see if I can find it. I can search for it actually. Mm. Um, I can open it on GitHub actually because I can't find it on Visual Studio Code, but it is on the repository. So let us walk through the repository as well. So this is the GitHub repository with a README file explaining how the system works. And then we also have our SDI pipeline that keeps failing. I'm not sure why. Could just be me. I'm not really familiar with it. Then we have a Docker Compose. So this is our Docker Compose that we didn't see before. So the Docker Compose basically sets up the connection to the Docker, which automatically runs the SQL Server DB, a Microsoft SQL Server 2002 container that serves as a database. It has a health check to ensure the database is ready before the API starts. Then secondly, we have the front end image and we have a back end which runs the API. So now we're going to go to PowerShell again. Okay, not that one. Let's close that one actually. We're going to go here. We're going to open a new one and we're just going to give it a second. I want this line of code here. And then just went there and then I'm going to say Docker this bold. Let me try that again. So because I already ran this before, it's gonna just do it again and then we can go to Docker. So just letting it run as it needs to. So while that's busy, I'm just gonna make sure that all my stuff is on GitHub since I did change some things while doing this demo. Uh, okay, and then I can just go back out. So while all this is running, I'm gonna go to Docker. Okay, I'll just let this finish. Actually, so yeah, you can see that everything is running on Docker now. So I can actually just say, see, so here is everything. So the SQL server is running here in the background. Um, basically the connection to the um. So containers, these are is the system running in the background. So each one has a link. Okay, it's not going to open now, but basically each one has a link. So this one will have a link, this one will have a link, and this one will have a link. So the front end one will obviously be the only one that actually opens, but they all obviously have to be running in the background for the front end to work. And then we have our images, which is here also. So yeah, that is, I think, everything for the assignment. I've covered all my bases. So basically, to summarize what we have accomplished in part 3, I refactored the system from a monolithic MVC application into a decoupled service-oriented architecture. The web API handles all database access, business logic, and authentication. The MVC front end is completely decoupled and communicates with the API using HTTP client and JWT tokens. JWT barrier token authentication secures all administrative API endpoints. The shared class library ensures model consistency between the front end and the back end. And I implemented 16 automated tests, including integration tests that look up the API in memory and verify security, data integrity, and end-to-end workflows. Finally, I containerized the entire system using Docker with multi-stage Docker files and Docker compose, allowing the database API and web app to run as a single orchestrated unit. So thank you for watching. I hope I covered everything. This is quite a long video, but thank you for watching.